Let's take a look at the first part of our problem. During a recent year, one basketball team made 108 out of 126 free throw attempts, and another basketball team made 195 out of 257 attempts. Does anyone play basketball or watch basketball? Can you tell us what a free throw is? Okay, so there's a player standing by themselves on the free throw line, and they try to throw the ball into the basket. Okay, so what does it mean to make a free throw? Or maybe what does it mean when you don't make a free throw? Okay, so when you make a free throw, that means you threw it and the ball went into the basket. Yeah, and that means the team got a point. But sometimes you don't make it and the ball doesn't go in, team doesn't get a point. All right, so that's helpful for thinking about what it means when the problem says a team made 108 out of 126 attempts. So 108 times it went in the basket, they got a point. The rest of the time it didn't. Okay, so let's move on. Angel drew these pictures to help them think about the percent of free throws made by the two teams. So I want you to take a second. What do you notice about these drawings that Angel was making? And what do you think Angel was trying to do with the drawings? So first, what do you notice? Yep, there's a bar for each team. What else? Okay, yeah, so the percents are written across the bottom. So we have 0%, 25%, 50%, 75%, 100% across each one. It's good to notice. What about the numbers on the top of the bars? So they both have 0, lined up with the 0%, that makes sense. But team 1 has 126 above the 100%, and team 2 has 257. What do those numbers mean in the problem? Yeah, it's the total number of attempts for each team. It's the out of number, right? So what do you think Angel was trying to do with these percent bars? Seems like he was trying to change those ratios to be a percent. Why would he want to do that? One way to think about it is to realize that it might be easier to compare the two teams with the percent. So remember, percent means out of 100. So when you're changing the ratio to a percent, we're changing them both to have that same out of number. So we'll be thinking about how many free throws each team made out of 100. That'll be easier to compare because if we look now at 108 compared to 195, that's the number each team made. We could just say that team 2 made more, but team 1 only had 126 chances, so it doesn't really seem like a fair comparison. But if we stay thinking in terms of the ratios and just change it to have that same out of number, it's easier to make a fair comparison. Okay. Why would we want to compare the two teams? Why would anyone want to do that? Yeah, I think there's a lot of reasons you might want to know that one team is doing better with free throws than the other. Maybe it's a coach who has two teams and wants to see how they're doing. Or maybe they're two teams that compete against each other and fans just want to know. I think there's a lot of reasons. Okay, so if we want to use these bars to help Angel and keep showing or change them to show the percent that each team made, what could we do? What could we add to these drawings? Yeah, that seems like a good first step to me, is to think about what numbers would go above the other percent benchmarks. So we have the 0 and 100% for each team, but what would go above these other percent marks? I think that's a good thing to figure out. What else? What other information do we have that we need to show in these drawings? Yeah, Where does the 108 go and where does the 195 go? That's the number of attempts they actually made. And we need to know where on these percent bars those numbers would go. So that's part of what I want you to figure out, is how to complete these bars for these two teams. There's some things to keep in mind, though. This is kind of a new representation. We haven't been working with bars like this before. We've been thinking about percents, but we haven't done a lot of work yet, and there's just generally a lot of numbers to keep track of in this problem. So you're probably going to make some mistakes. That's okay, though, especially because we've been working on debugging, which is one of our CT practices. So debugging is finding and fixing mistakes to improve your work. So it's fine if you make mistakes. We're just going to look for them, fix them, and our work will get better. So there's two things we're going to do today to help you with debugging. The first is every once in a while I'm going to say stop, and I just want you to compare your work with a partner. And when you do that, you'll be able to see if you're both getting about the same answer, or maybe if you're getting very different answers, that might indicate one of you has made a mistake, and you can work together to fix it. Could also mean you're just doing the problem in a different way, and that's okay too, but it can be really helpful to check to help you find and fix errors. And then the other thing I'm going to ask you to do is try to think about keeping little notes about your thinking as you go. So for example, if I decide that I'm going to use 60, that makes sense to me as the number that's going to go above 50% for team 1. And then I compare with a partner, and my partner has an answer that's a lot different. I might want to think about how I got that number 60 to see if I made a mistake. But if I haven't written anything down, it might be hard for me to remember why I wrote 60 there. But if I'm working, I just make a little note and say, well, to find my 50% mark, I'm just going to think of 126 as close to 120. And then that's an easy number. I can take half of that to find a 50%, an estimate for 50%, and that's why I wrote 60. So then I'll be able to review my thinking better and probably better able to fix my mistakes. Okay, so those are two things I want you to think about. Try to make notes as you work, and every once in a while I'll tell you to stop and check with a partner and see if you can do some debugging. I was walking around as you all were working, and there was some really great debugging going on. I think you all did a great job with your debugging. I asked one partnership if I could share what they did to debug, and they said it was okay. So I'm going to talk about that with you. I'm just going to call these two students red and blue. And these are their bars for team 1. So this isn't team 1 and team 2. This is red's bar for team 1 and blue's bar for team 1. So the first time I asked them to stop and compare, they had only done the team 1 so far, and they just compared that part. And they noticed, wow, our shading is in a really different place. So I think maybe we have a bug somewhere, a mistake that we can fix. So the first thing they talked to each other about is why they had put their shading where they did. And blue said, oh, I wrote that down. I put 108 here because 108 is between 60 and 180, and those were the two numbers I had for 50% and 75%. So that's why my shading was there. And red said, oh, that makes sense. Actually, I did something similar. It was smart that you wrote that down. I'll add that. But in my case, I put it between 75% and 100% because that was between what I had written there. 108 is between 94.5 and 126. So in thinking about where 108 is relative to their benchmarks, that wasn't a mistake. They had done that okay. So then they started thinking about the other things they could compare. So what about those percent benchmarks? They looked at 25% first, and red had 31.5 and blue had 30. It's pretty close. Seems like those could both be okay estimates. And then red had 63 and blue had 60 for 50%. Those seemed pretty close. But then when they got to 75%, red had 94.5 and blue had 180. They were like, one of us, I think, made a mistake here. Who do we think it is? So red explained their thinking first and said, well, I was thinking about the total of 126, and I knew to find 25%, I could just divide that by 4 to get 31.5. And then I knew 50% would just be half of the total, so I did 126 divided by 2, and that was 63. And then to find 75%, I just thought of 75% as 25% plus 50%, and that was 94.5. And red said, that makes sense to me. I don't see any mistake to fix there. So maybe I can think about mine. But red had made those notes, so it was easy for red to explain their thinking. Blue hadn't done that yet. So all he had to look at were these numbers, but the first thing he noticed was that 180 that he had for 75% was actually greater than 126. And why doesn't that make sense? Yeah, we can't have 75% being more than the total. That doesn't make sense. So he agreed that there was probably a bug there to fix. So he didn't have notes yet, but he added some more to just try to think about what was it that I did to get these numbers. And blue made estimates. Blue thought of 126 as a number close to 120 and used that. So he said, I know that half of 120 is 60, so that's my estimate for 50%. And then half of 50% would be the same as 25%, so half of 60 is 30. And then they thought of 75% as 3 times 25%. And so 3 times 60 is 180. But then once he had made those notes, he realized I didn't do 3 times my number for 25%. I actually accidentally did 3 times my number for 50%. So all blue had to do was make a little correction and say, actually, this should say 3 times 30 is 90, and then that makes sense. My shading would move to be between 75% and 100%, just like red had. So together they were sharing their notes, and they were able to find the mistake. So this pair actually said having those notes was really useful for debugging. Were the notes useful for you too? Who else would like to share their debugging strategy?